excited to be I'm very excited to be teaching all of you. So I'm just gonna share my screen with today's lesson. So today we're gonna be learning about sequences and series. Are any of you familiar with sequences and series? Okay. So first we'll start off with like the definition of what a sequence and a series is. So a sequence is basically a set of numbers, so like 1, 8, 15, 22, that has a common difference between the two numbers. So there are two types of sequences you can find. One would be a geometric sequence, where the difference between two numbers would be a multiplying factor. So let's say we had the sequence like 1, 4, 16, 64, and so on. The difference between the two numbers would be multiplied by 4. So 1 times 4 would be 4, and then 4 times 4 would give you 16, and so on. So this is called a geometric series. Another type of series you might find are called arithmetic series. So it's like this example here, where each number is represented by the first number, let's call x of 1, plus a common difference called d. And so the series would look like x1, comma, x1 plus d, comma, x1 plus 2d, and so on. So the common difference here would be added instead of multiplied. And then in a series, you would start summing these numbers. So there are certain formulas for like the sum of a geometric series and a sum of an arithmetic series. So does anyone have any questions right now? No questions? Okay. So we'll go over the sum for an arithmetic series. So the sum, sum of an arithmetic series would be the number of terms, which is n, times the first term, which is, let's say, a1, plus the last term, which would be like an, divided by 2. And then the sum of a geometric series would be, the number of terms, it would be the number of terms n times 1 minus r to the n. So r here would be like the common ratio between the numbers. So if we look at the geometric series I had written out before, it would be 4. So you'd have the number of terms times 1 minus, not number of terms, it would be the first number. Sorry about that. So it'd be,
Please impressed
I said when I got some of the teachers we had everybody present, everybody around this except Mr. Obey, promised to be.
Sorry, please. I would just encourage us to mute our mic. If you would like to make any concerns, kindly use the chat box and we would unmute you.
Sorry. The MD was there, as Foster said, he came in.
Sorry, what background is that? Can Varini? Yes, it's on record, please. We would like everyone to mute their mic so that it doesn't distract the facilitator. Kindly drop your questions on the chat box and we would help you out. I'm so sorry, please.
Okay, so back to the formula for a geometric series. So this would be the first term, which is a1, times 1 minus r, which is like the common difference, over 1 minus r. So yeah. And then the types of problems you'll find with sequences and series is finding the last term of the sequence, adding or subtracting terms to find the answer, and finding how many terms are in a set of numbers. So we'll go over a couple of these problems right now. I'm gonna clear the screen. Okay. So in the sequence 2, 5, 8 to 11, or 11 to 449, what is the value? If 449 is the nth number, what is the value of n? So I'll give you guys some time to maybe think through the problem, and then I can go over the solution. So just give it your best attempt, and then in the chat box, maybe you guys can put some answers, and then I'll go over them. Yeah, I can refresh. What exactly do you not understand? Or do you just want me to like go over everything again? Okay, I'll just go over everything then. So within mathematics, there are two types of, I guess, like lists of numbers. We call them sequences and series. So, okay, yeah. So there are two types of like lists of numbers in math. One are called sequences and the others are called series. So the key difference between a sequence and a series is that a sequence does not have operations. And what I mean by that is basically a sequence only has like commas. It's literally a list. However, a series, like this one, there are operations. So you can see there are like, you can see that there are like plus, minus, and like you can even multiply them together. There are different operations that you can apply to series, and that's what makes them a series. So there are two types of sequences or series we have. So one of them is called an arithmetic series. Or sequence. So basically these ones have their sequence is basically made up of a common difference that you add to the first term. So let's say we have a sequence where the first term is x1. Then the next term in the sequence would be x1 plus some d. This d is known as the common difference, and you can like build the rest of the terms of the sequence or series using the common difference. So if you keep going, it'd be like x1 plus 2d, and then x1 plus 3d, and it just keeps going. So if we were to look at like a real example, we could have like 1, 3, 5, 7. So the common difference here would be 2. And then the first term would be 1. And then the second type of series is a geometric series or sequence. So what this is basically now there is, instead of adding a common difference, you'd multiply by it. So if x1 is our first term again, we'd get x1, comma, x1 times d, comma, x1 times d squared. So you just keep multiplying by d to get the next term. So if we were to look at an example, it'd be like 1, 4, 16, 64, and so on. So here, the difference would be 4, and the first term would be 1. So you can see that this would be 1, and then this would be 1 times 4, and then this would be 1 times 4 squared, and then 1 times 4 cubed, and so on. Does that make more sense? Yes, okay. So now we're gonna talk about some formulas. So I'm gonna erase the board. Does everyone have everything down? Or I'll give you like a minute to copy everything. Okay, I'm gonna erase the board now. Okay, there you go. Oh, do you want me? Okay. So now we'll go over some formulas. So the first formula is going to be for an arithmetic sequence or series. So this first formula will help you sum up all the terms in the sequence or series. So you take the number of terms, which is n, and then you multiply it by the first term, so a1 is the first term, and then you'd add the last term, so an, and you divide by 2. So that would be your equation for the sum of a series. So we can do an example. So let's say we had the series like 1, 2, 3, 4, 5. Let's say this was our series. So let's manually compute the sum. So we get the sum to be 15, right? So 1 plus 2 gives us 3. 3 plus 4 equals 7. And then 3 plus 7 plus 5 gives us 15, right? So now let's use the formula. We have, hold on one second. Let me just make sure I've got the right formula. Okay, so we'd get n, which is 5. Oops. We get 5 times the first term, which is 1. 1 plus 5, which is the last term, divide by 2. So if we were to simplify this, we'd get 5 times 6 divided by 2, which would give us 30 divided by 2, which would be 15. So using the formula, we were able to compute the sum. Does that make sense to everyone? Yes? Okay. Any questions so far? No questions? Okay. Okay. So now I'm gonna go over 2 more formulas. Let me just erase this. Okay, so the next formulas we're gonna go over are for a geometric series. So there are 2 types of geometric series. There are finite geometric series and infinite geometric series. So the first one would be a finite geometric series. So finite geometric series or sequence. What this means is that the sequence ends at one point. So let's say we have the sequence like 1, 2, 4, 8. This is the sequence. There's no dots, meaning it doesn't go on. So the formula we'll use for this type of sequence or series where it ends is A times A being the first term, times r to the n, so we have r to the n, minus 1 over, so r in this case would be our d. So r is equal to the common ratio. So basically whatever you're multiplying here. So if you multiply by 2, this would be our r. Does that make sense to everyone? Okay? Okay. So then, let's continue with the formula. It'd be all over 1 minus r. So this would be, what part do you not understand? Whoever said no. I can just re-explain what I wrote on the board if that will help. Oh, every part of the formulas that I went over? Or like the definition? Oh. Like, definition, okay. So the definition of a sequence is basically like a list of numbers. So this would be an example of a sequence. Oh, just finite? Okay, so what the finite sequence means is like it ends. So there's infinite and finite. So like if I were counting something, if I were like counting the number of apples I had, so let's say I had 5 apples. That's a finite amount of apples. I don't have like an infinite supply of it. Okay. So do we understand finite, or is there something else that's not being understood? No? Okay.
Yeah, I do. I'm looking for pen. So where is that pen we're talking about?
Okay, so let me just like go over the definitions again, and then we can continue with the formulas. So there are a couple of main, I guess, definitions we should go over. So first, sequences. Did everyone understand what a sequence is? Yes. Oh, the ratio part. Okay. Okay. Does everyone understand what a series is? I'll go over the formulas again. I just want to make sure like everyone understands the definitions before. Okay, so I'll explain what a series is for those that don't know. So a series is basically a sequence, but there are operations in the series. So like if we look at the example, explain there. Yeah, I'll get to that. I'll do that next. But everyone understands what like the basic series is outlining, right? Okay, so there are 2 types of series. We have an arithmetic series. For those that understand, why don't you explain what it is? So just like type a definition in the chat. Okay, I'll just quickly go over everything and then we can move on, I guess. Okay, an arithmetic series is you're adding a term. So you're adding a difference d. And then a geometric series, you are multiplying by a ratio r. Is everyone clear what's going on?
No, can you please go again?
Okay, yeah, I can. Both of them or just like one of them?
Both of them.
Okay, so yeah, whoever raised their hand.
Please, I don't understand the meaning of the arithmetic series.
Okay, so basically an arithmetic series, think of it as like you have one apple. So here's one apple, right? So in an arithmetic series, the next term or the next amount of apples you'd have, you'd add some d, or like you'd add some other number, and this number would be constant. So let's say between every time you add one more apple,
Okay.
right? So
Yes.
in the arithmetic series, your next term would have two apples, right?
Yes.
And then this would keep going. So your third term would have three apples, then four apples.
Oh, yeah. I now understand.
Okay,
Please, I
yeah.
didn't learn ratio when I was in school.
And then just one more thing. You can change this difference. So you can make this like plus two apples instead. And then
Okay.
that would make the next term three apples. And then instead of three here, it'd be 3 plus 2, or 5 apples. And then 5 plus 2, 7 apples. Does that make sense?
Yes, please.
Okay. Then we'll go over a geometric series next then. So then with a geometric series, instead of adding some d or difference, I'll explain the ratio now.
Okay.
The next, the geometric series, you'd multiply your first term, so let's say one apple, by some r, which is a common ratio between all the elements. So let's say our next term was like 3 apples, right? Our r would
Yes.
then be 3 over 1. So it's basically the ratio between both the terms. Does that make a little more sense, or no?
Yes.
Okay. Let me see what else. So let me make so we all understand what a geometric series is, right? It's where you basically like multiply by something to get your other terms. So like so if I had one apple and I multiplied that one apple by, let's say, 2, then my next term would have 2 apples, right? And then, so the ratio then between these two terms would be 2 apples over 1 apple, right? So our r would be equal to 2. So to find the ratio, you'd basically put the next term over the first term. And then this ratio will stay constant throughout the whole series. So our next term, we'd multiply 2 by 2, right? And we get 4 apples. Okay? Does that make sense?
Okay.
Yes. Okay. Okay. So there are 2 types of geometric series. So I'll just leave that on here. There are 2 types. Finite, meaning like ending, and infinite, meaning never ending. You don't add a constant number, you multiply by a constant number. So let's say I changed r from 2 to 3. Then instead of having, okay, let's try this again.
Please, everyone, let Madam talk. Want to shut up.
Okay. So, let's see. Okay, let's start with the apple example again, right? So you have 1 apple, right? And every day, someone will give you 3 times the amount of apples. Huh? Can you hear me?
Yes.
Okay, so let's say every day I give you 3 times the amount of apples you have. Right? So this is day 1. You start off with 1 apple. So the next day, I'm going to give you 3 times the amount of those apples, right? So what would be the next term? How many apples would you have on day 2? Oh, I'm explaining the ratio right now, so don't worry. 3, yeah. You'd have 3 apples. How about on day 3? On day 3, how many apples would you have?
6.
Not 6, because
Oh,
you have 3 on day 2, right? And I'm going to give you 3 times the amount of apples you have. So on
9.
day 3, I have 3 times 3. Yeah, so I have 9 apples. Okay, let's do one more. How about day 4? How many apples would I have on day 4?
11.
So you're not adding
27.
3.
Playing
Huh?
Verda, I guess it's
27.
in
Yeah,
that side.
27.
I think
Yeah, 27. So basically, what you've just done is build a geometric series where you're going to have your terms be 1, 3, 9, 27, right?
How did she get it instead?
So the way you get 27 is that on day 3, you have 9 apples, right? And every day I'm going to give you 3 times the amount of apples you have. So on the 4th day, if you have 9 apples, I'm going to give you 3 times the amount of apples you have. So I'd give you 9 times 3, which gives you 27. Does everyone understand how that works?
Yes.
Yeah?
Yes.
Okay.
yeah.
So now let's talk about the ratio, right? So
Yeah.
the ratio can be a little bit confusing. So we'll go through this a little slowly. So basically the ratio is going to be between a number. So you're gonna take basically like the a number before one position and then put it over the one after, like previous. So if we were finding the ratio of this series, we'd basically do 3 over 1. So our ratio would be 3 over 1, which equals 3.
So it's every number times 3.
Yeah. So this is the ratio is the number you multiply.
The ratio
Okay.
2 over 1.
Does that make a little sense-ish?
Yes.
Yeah?
Yes.
Is anyone
Yeah.
still confused?
Yeah.
Oh, the
No.
ratio is basically what you multiply by to get the next terms. So I'd multiply 1 by r to get 3. Then I multiply 3 by r to get 9. And then I multiply 9 by r to get 27.
Yeah.
Yeah.
So
Ratio is that.
everyone get that?
Yeah.
Yeah.
Yes?
Yeah.
Okay,
Yeah.
let's go back to the two types of geometric series. So you have a finite geometric series, which means it basically ends. So like, let's say after 5 days, I stop giving you apples. That would be a finite geometric series because your series would end there. So, the finite geometric series would be if I stopped giving you apples on day 5.
Sorry, please. Someone's iPad, quad wall iPad. I think you may need to mute because you're not speaking. There's some background noise from your end, please.
Okay, so I stopped giving apples on day 5 would represent a finite geometric series. Does that make sense? Yes?
Yes,
No?
it does. Yes,
Okay.
it does.
I'm gonna erase the screen a little bit. Is that okay?
Yeah.
Yeah?
Yes.
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 You said it.
Hmm? What?
Oh, so please keep quiet.
Okay. So let's say, so we're going over in finite geometric series. Right? So basically, let's go back to the apple example, right? So every day I will give you 3 times the amount of apples you have. Right? So day 1, you have 1 apple. Day 2, you have 3 apples. Day 3, you have 9 apples. Right? And so on. So an infinite a finite geometric series would be like, instead of every day, I only gave it to you for 5 days, right?
Okay.
So instead of having this dot 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 here, we'd actually just have until day 5. So
Okay.
it had day 4, where we computed it'd be 27, and then day 5, which would be 27 times 3, which is 81, right? This is our finite geometric series. Because I stopped giving you apples, your series can no longer continue. So a finite geometric series does not go on for infinity. It stops at a certain point. Does
Okay.
that make sense?
Yeah.
Yeah. Yeah.
Yes.
Okay. Okay. So the equation for a finite geometric series, or like the sum for a finite geometric series, would be, okay, formula. Oh, here's the formula. It'd be the first term in the series, so that would be like 1 in this case, times 1 minus 1 minus r, which was the common ratio between the two. So in this case, r would be 3 to the nth power. So
Please, is it
for n, huh? Okay, where n represents the number of terms over 1 minus r. So let me just write down on the side. A is the first number. R is the ratio, or like common ratio. N is the number of terms.
Hello, Instructor Varini. One more thing, sorry. Dorcas is raising her hand. I think she wants to understand the n factor in the formula, please.
Oh,
Hello? Yeah. Yes. Please, I wanted to ask if the formula was for only finite or for geometric in general.
it's only for finite. So only if the,
Okay.
yeah, so basically in an infinite geometric series, there is no n, because you don't know how many terms there are in the series before it's like, because it doesn't stop. So we'll go over the infinite next. But does everyone understand finite geometric series?
yes.
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 Okay, and was
Yes.
everyone able to copy down the formula?
Yes.
Yes.
No.
Okay,
Yes.
I'll give you guys a couple more seconds, I guess, to copy it down. Does everyone understand the components of the formula?
Yes.
Yes.
Okay.
Yes. Yes.
No?
Please, Roger says he doesn't understand the formula.
Okay. Roger, do you wanna like kind of specify what part you don't understand?
Types of problems. How long?
You don't understand. Wait, can you say that again? Okay, I'll just re-explain the parts of the formula and then we'll move on to infinite geometric series. So A is the first term of the series. So if we were looking at like the example of apples per day, like day 1 is 1 apple, day 2 is 3 apples. Okay, yeah. So day 1 is 1 apple, day 2 is 3 apples, and so on. We'd have the series 1, 3, 9, 27, 81, right? This is just basically this. So if we're using the formula to find the sum of this series or like sequence, we take the first term, which is 1, and put it in for A. So we'd get 1 times 1 minus our common ratio. So our common ratio is going to be the ratio between the terms, right? So in this case, our R would be equal to like 3 over 1 or 3, right? So now we're going to have 3 to the nth power. So n is going to be the number of terms, right? So let's count. There's 1, 2, 3, 4, 5. 5 terms. So we're going to have 1 minus 3 to the 5th over 1 minus the ratio 3. And if we simplify this, we should get the sum of this formula or this sequence. Does that make sense?
Yes.
Oh, if you had to find, you'd use this formula if you needed to find the sum of a sequence or a series.
Okay.
I don't understand the formula.
Okay. What part do you not understand? Like how to use it or like what it is or
I don't understand every part.
okay. Do you understand the concept of like a finite geometric sequence or series?
Yes, but it's the
Okay.
formula I don't understand.
Okay, so the formula is basically where you just like plug in numbers. So, let me erase some of this stuff. Okay, so here's the formula, right? This over here. So basically, you'd put the first term of the sequence here. So like in our example, our first term was 1 because we had 1 apple on day 1. So we put in 1 there. Then we multiply 1 by 1 minus the ratio, which was 3, right? 3 to the number of terms we have because we know that it ends at one point. So we know we can count the amount of terms. So in our example case, we had the ratio is like, so the ratio is the common multiplier between the terms. So basically what you multiply to get the rest of the series. So like you multiply R here.
First, I have to also copy. They say we have to copy.
Okay, and then so you have the number of terms in your series, which is n. Do you understand that part so far? Like,
Yeah.
does that part make sense? Okay. And then the last part you do is you just divide by 1 minus the common ratio.
Stop talking and listen.
Does everything make sense? Everyone's good? Yeah, I'll post an assignment. There'll just be like some simple practice problems that you guys can go through, and I will post the solutions as well.
Okay.
But Yeah. Okay.
Okay.
Last sort of
Okay.
thing. I'm gonna erase. Is everyone okay with me erasing? Yes.
Yes, please.
Okay, yes.
Yes.
You can erase.
Yes.
No.
No?
Yes.
Cynthia, why? Why don't you want Madam to read it?
Mommy.
Okay, I'm erasing.
Yes.
Yes, ma'am.
Yes.
Okay. So the last thing we'll go over are infinite geometric series or sequences. So does anyone remember what I said about infinite geometric series or sequences? Do they stop or do they just keep going?
They
They
keep
keep
going.
going.
Yeah. So
They keep going.
yeah,
Continue.
They keep going.
They don't stop.
yeah. You don't stop. They don't stop. So what that means is that let's like I'll just give you the formula because I think you guys understand how this works. So the formula is going to be the first term, a, divided by 1 minus r. This is the formula for an infinite geometric series, but r must be less than 1. R can't be greater than 1.
Can you explain the formula?
Oh yeah, I can explain.
Greater
So
than one.
a is going to be the first term in the series or sequence. And then r is just again going to be the ratio. But r has to be less than 1. If r is greater than 1, then you can't have an infinite geometric series. Basically, let's say we have like 2, 1, 1/2, 1/4, and so on. What would be the r here? Can anyone tell me what the common ratio would be?
Half.
Half.
Yeah, half. So it would be 1/2, right?
No.
No? Why wouldn't it be 1/2? Does everyone
I
understand why it, huh?
Who said it's quarter? Who said it's quarter?
Does everyone understand why it's 1/2?
No.
no.
Okay. Remember
Yes.
we take the term previous, like the second term, and we'll put it over the first term to get the ratio. So if we do that, we get 1/2, right? Same thing if we do it like with this term too, and this one. If we do 1/2 divided by 1, how much do we get?
Quarter.
Yeah. Does that make sense to everyone? How we
Yes.
got 1/2?
Yes.
Yes.
Yes, please.
Okay. Yes? Okay.
No.
Yes. Yes, please.
Yes.
Okay. So basically, just to like recap, to get the ratio, you take any pair of terms. So you take like a pair of terms. And you take, so this is our pair of terms, 2 and 1. And you take the rightmost one and you divide it by the other one. So you get 1/2 for this. Does that make sense to everyone or no?
Yes.
Yes.
Yeah.
Okay.
Yes. Sorry for my background. It's quite.
Okay. So then let's talk about
Please.
oh, okay. So yeah, then going back to the formula,
It's unnecessary.
everyone, does everyone understand the formula?
Yes. No.
Yes.
No.
Yeah.
Okay, those that are saying no,
Yeah.
what part do you not understand?
The formula, I don't understand the A.
A is gonna be the first term.
Oh,
So like if I have the series 2, 1, 1/2, 1/4, A will be 2. This is it. It's your first term. Okay, does everyone get it now? Yeah.
yeah.
Yes.
Then.
Yes.
Yes, please.
Yes,
Okay.
please.
Mm.
Does anyone have a question?
Yeah.
Please.
No,
Okay.
please.
No questions?
I have a question.
Yeah.
You said if it's greater than one, the if the ratio is greater than one, it won't be infinite.
Okay, so for you to have an infinite geometric series or like use this formula to get the sum, the ratio between the terms has to be less than 1.
Okay.
Uh, in the formula. Okay, yeah. So the formula is basically you have the first term of the sequence. So like, yeah, the first term divide by 1 minus the common ratio. Okay, any more questions?
No.
Okay.
Everyone's
No,
okay?
actually, maybe she will ask a question again.
What? Wait, sorry, can you say that again?
I said that you should ask again because you think questions are necessary.
Okay. Okay, I'm gonna move on. Everyone okay with that? Yeah?
Yes.
Okay.
Yep.
Yep.
Okay. So now we're gonna just review the types of problems. So one type of problem, yeah. One type of problem is you're gonna have to find the last term of the sequence. And then the other types is like adding or subtracting, so finding sums. And the last one is just finding how many terms. So we'll go over those types of questions right now. Okay.
Please, can we move forward?
Yeah.
Madam,
Okay.
please come. A is the first term of the sequence in the series.
Yeah, A is the first term in the sequencer series. Okay, so why don't you guys try this problem? So you have the sequence. I'm gonna give you a hint. It is an arithmetic sequence.
Okay.
So, what do you think the like the term number of 449 is? Does everyone understand the question?
No.
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 So you have the sequence.
No.
No.
Okay. Yeah, so
No.
you have the sequence, right? And 449 is some
No,
term
please.
in the sequence, right? Everyone gets that part so far, right? You have the sequence, and 449 is a term in the sequence. Good?
Good.
Yeah? Okay, so what the question is asking you to find is how many numbers like, I guess, if 449 is a term in the sequence, what term is it? Like, what number is it? Like, if you ask me what number 2 is in the sequence, I'd say 1, right? You ask me what 5 is, I'd say 2. So now what it's asking you is, what is 449's number? Does that make sense to everyone?
96.
Yeah.
Okay, so I'll give you some time to solve the problem, and then we will go over the solution. Okay?
Okay.
Okay. If you come up with an answer, just let me know in the chat.
Okay.
Okay?
Okay.
Great. Please also private message me your answer. So if you get it correct, it doesn't like spoil it for anyone else. Please private message me your answers.
Rina sent the answer.
Okay. I think we're all a little confused on how to do it, so I'm gonna go over the solution. So basically, let's think of it this way. We know how each term relates to each other, right? So if I wanted to see 5, or let's start with this. An arithmetic sequence is set up in a way such that you have like x1, you have x1 as the first term, and then the second term would be x1 plus some difference, right? And then x1
898.
to,
I think it's 898.
I think that number is too big. I think you're on the right track though. So I'll go over the solution and you can see if you can see where you kind of made a mistake maybe. Okay. Does everyone understand that this is like the setup for an arithmetic series? Does this make sense to everyone? Why it's set up like this? Yes? Yes? Okay. So using this,
No.
let's see. Oh, no? Okay, so remember in an arithmetic sequence, we add some difference, we add some d to each term to get the next term. So you know how in like a geometric series, we do x1 is, and then x1 times r, and x1 times r squared, so on? This would be a geometric series.
Shouting.
Okay, let me give you an example of how this is sort of set up. So let's say we have like one apple again, or like, so let's say on day 1, you have one apple, and every day I'll give you 2 additional apples. Right? So every day I will give you 2 more apples than you had the previous day. So then day 2, how many apples would you get? Or how many apples would you have?
2.
3.
You'd have 3 apples, right? You started off with 1 apple, and I gave you 2 additional apples. So then day 3, how many would you have?
50. 50.
50?
50. 15.
How did you get 15?
5.
Yeah, you'd have 5.
3. 5, 3.
No. I'm only giving you 2 additional apples per day. So that means you have to add 2 to your previous day. So you get 5 apples.
Will it be 12?
What? This is an arithmetic series or sequence. I think you guys are thinking about a geometric series. This one you add. So let's try day 4. How many apples would you have day 4?
7.
7. Yeah. Okay. So we can represent 3 apples as 1, the first term, plus D. What is D in this case?
Difference.
Yeah.
Will it be 14 apples? 12 apples.
For day 4, the answer is 7 apples.
Yeah. 12 apples.
No, not 12.
That is 9 apples. Day 5 is 9 apples.
Okay, so now we're moving on. How would we represent 3 in terms of the first number, given that we know that an arithmetic series has a setup like this?
2.
Yeah, so you do 3 plus 1, and then times 1 times 2, right? So we do times or plus D, right?
Yeah.
So then if we were to set up 5, how would we do 5? 5 would be 1 plus 2 times 2. Does that make sense to everyone?
Yeah.
Yeah?
Yeah.
Okay, so now let's go back to the problem. So, knowing this, how would we represent 449 in terms of D?
No.
Huh?
430.
Okay, so we'd represent 449 in like this. 449 equals 2 plus x times the difference, right? The difference between the terms. So what is the difference?
That you
3, yeah.
Oh.
Okay? So then
It's gonna be 11.
It's not 11. So how would we solve for what, how would we solve for what, oops. How would we solve for what x equals? We do 449 minus 2 equals 3x, right? So how much is 447, right? So we get 447 divided by 3 equals x, right?
Yes.
Okay.
No, I don't understand.
I don't understand what you're saying, madam.
Okay, let's think of it like this. Wait, I think one person got
Madam,
the,
you said
let's do this. Hold on. I have a
Please,
table.
if the difference is 3, how come it's 447? Please, if the
Madam,
difference is 3,
I'm
how
getting
come it's
confused.
447?
Wait,
Okay,
Madam,
here.
I'm getting confused.
Okay,
Me too.
yeah. I'll try and help explain. Okay, let's look at the table.
Please, could you give another example? An
Papa,
easier
Marina,
one.
can you give me the
Can you give an
process
easier
of the
example?
order and the end and the sequence?
Example.
I don't understand.
Okay, yeah, we'll go through this problem again slowly so you guys can understand what's going on.
Thank you.
Thank you, madam.
Let's look at the order, or let's look at the
Okay.
table. So we have the
Okay,
first number.
is 1.
Yeah, so we have the first number is 2, right? The first number in the sequence is 2, right? The second number
Yeah.
in the sequence is 5. The third number in the sequence is 8. Everyone gets that?
Yeah.
No.
Okay.
No.
What? No. All I'm doing is like listing out the numbers. Like, if you were to go through the sequence, it'd be 1, the first number in the sequence is 2. The second number in the sequence is 5. The third number in the sequence is 8. Right? If you count it, 1, 2, 3.
I now understand.
Yeah, I understand now.
I understand now.
Oh, okay. Okay, that's good.
Me too.
So now let's look at the difference between these two numbers. The difference here is how much?
3 and
Yeah, it's just 3. How about the difference between 2 and 8?
is 6.
Yeah,
5.
6.
6.
Yeah. How about between 2 and 11? Between 2 and 11?
9.
9.
9.
Yeah.
9.
Yeah. So you see how this sort of order number correlates with how many times you multiply by 3 to get the next number?
Yeah.
Yeah?
Yeah.
So
Can
to get 11, you do 11 equals 2 plus this number, let's call it x. 2 times x minus 1 times d, right? Everyone understand how I got that?
Yeah.
Yeah? Okay, what is d?
D is difference.
D is 3, right?
Yes.
Yeah?
Yes.
Okay, d is 3. What is x for 11? What is x?
Very good.
X is 4, right?
Yes.
Yeah. Okay, so it'd be 4 minus 1 times 3. This gives us 11, right?
Yes.
Yeah. Okay, so now that's how we define 11. Now let's define 5. Who wants to give me the answer for 5? How would you define 5?
So
Five.
5 will be equal to
14.
It'd be equal to 2 plus, this would be x,
2 plus x
right?
minus t and a.
Does everyone understand how I got this?
No,
The question.
yes,
not really.
I'm confused.
Go.
Okay, so
Please.
okay, so you take the first term, which
Okay.
is 2, right?
yes,
Everyone understand that? 2
Yes.
plus
Yes.
1 gives you 5. 2 plus 3, right? Gives you 5. Yeah? So the way you'd look at this problem is that you see the amount you get 5 based on what position it's at. So 5 is at position 2, right?
doesn't mean that
Nama saya Raya yang ketujuh. Yang ketujuh.
doesn't mean that
9.
the number minus 1.
Oh, someone's unmuted. Okay. So, okay, let's go through this again slowly. So we have that 5 is at position 2 and 2 is at position 1, right? So based on these positions, how can we represent 5? So we can do that like a of n, so the term n equals to a of 1, which is the first term, plus the position of the term we're looking for. So in this case, it'd be 2, but the position, let's say x, minus 1 times d, right? Because let's say,
Madam, please, I don't understand what you are saying.
okay, so the way this works is like we add 3 here,
Is
right?
the answer 9?
No, the answer is 150.
Madam, please, how come the number answer is 150?
Yeah, I'm explaining how the answer is 150.
Madam, please, I'm still having trouble understanding.
Yeah. I understand. Okay,
How is the answer gotten?
so the way you get the answer is let's look for patterns. Let's see if we can formulate a pattern that we see. And then based on the pattern, we can make an equation and use the equation to solve for the answer. So the key thing that we need to do is we needed to create a correlation between the position the number is at and the number itself. Everyone clear on that? What we need to do? Yes, no?
No.
Okay.
Oh,
Okay,
No.
okay.
No.
So
No.
what we need to do is we need to find what position is 449 at, right? That is what our main sort of problem is, correct?
Yeah.
Okay, so we're given 449 is the number. So what we need to do is we need to see how we can get the position from the number itself, correct?
Yeah.
Yeah? Okay,
Yeah.
so let's start small. Let's look at 5. 5, we know the position and we know the number. So let's see if we can come up with like a pattern that we see that can help us find the, yeah, right? So we know that 5 is at position 2, right? Everyone clear that 5 is at
Yes.
position 2?
Yes.
Okay. And how much of the difference do you add to 5? Like how many times do you add 3 to 2 to get 5?
Once.
Yeah, 1 time. So I'm only gonna do 1 times 3, right?
Yes.
What is 1? How else can you represent 1?
Let's use an 8.
2 minus 1, right? Will also give you 1. Everyone clear on that? That
Yes.
2 minus 1 will also give you 1?
Yes.
Yes.
Oh,
Yes.
what is 2? 2 is the position of 5, right?
Yes.
So are we seeing a pattern here? 5 is equal to 2 plus 2 minus 1 times 3, right?
Yeah.
Yeah?
Yes. Yes.
Okay, so now let's try it with, let's say, 11. What is the position of 11?
4.
4.
4.
Okay, so how much do we add to 2 to get 11?
9.
Yeah. How else can we represent 9? We can represent 9 as 3 times 3, right?
Yes.
Yes.
It's 3. How else can we represent 3?
3 plus 3 plus 3.
No, just 3, just 3. It's 4 minus
1
1.
times 3.
4 minus 1, right?
Yes.
So look again, it's the position minus 1, right?
Yes.
Everyone
Yes.
clear? Okay,
Yes.
so now we can come up with a formula, right? So we can say A of n, which is like any term in the sequence, equals to 2 plus n minus 1 times 3, right? Where n is the term number. So if we want to say like A of 2 would be 5. Is everyone clear on that?
Yes.
Yeah?
Yes.
Okay,
Yes.
so anyone want to guess how we can figure out what n is? Where can we plug 449 into? We can plug 449 into A of n, right?
Yes.
Okay, so 449 equals 2 plus n minus 1 times 3, right?
Yes.
Okay, so then let's solve this equation. Do we know how to solve equations?
Yes.
Okay,
Yes.
so what is the first step
Yes.
I should do? What is the first step I should do?
You should multiply 2
Like
by n.
Wait, what person?
group like terms.
Multiply? So you want me
Find
to do
n.
this? Yeah, we're finding n, but what is the first step I should do?
You should multiply 2 by n and 2 by minus 1.
Okay, so we're gonna distribute, right? So we get 449 equals 2 plus 3n minus 3, right?
Yes.
I have to distribute this 3. Okay, what's the next step? Well, what should I do next?
You group like things.
Okay, yeah, so 449 equals 3n minus 1, right?
Yes.
Okay, next step. I bring 1 over to the other side, right?
Yes.
I add 1,
And it
yeah.
becomes positive.
Yeah, so I get 450 equals 3n. Now let's divide by 3.
3.
We get n equals 150.
Yes.
Everyone understand how that worked?
Yeah.
Yeah?
Yes.
No.
Okay. No?
Yeah.
No.
No. No.
Okay, so does someone who understood
I'm
want
so
to
confused.
does someone who understood how this works want to explain kind of how it works?
Me.
Okay, yeah, go.
So when you have 9 is equals to 2 plus 3n minus 3. You will have to send them 1 to the other side and it will become positive. So you add 1 plus the 449. Then when you finish the answer, to get n, you multiply it by 3. Then you get your answer.
But how did we come up with that 449 equals 2 plus 3n minus 3? How did we come up with that?
You multiply 2 by n minus 1 in the brackets.
No, but how did we come up with this equation? Like, how did we get that? What pattern did we find?
You replace AR with 449.
But how did we get this pattern? Like, where did this come from? This part. Does everyone understand where that part came from? Or no?
No.
No?
I think I forgot that place.
Okay, I'll go over it again.
Okay.
Okay, so what we found was a pattern between that correlated the position of something, the position, with the number itself. Okay?
Yes.
So let's look at 5. How can we take 5's position of 2 and get the number 5? So let's look at the common difference. We know that the difference between 2 and 5 is 3, right?
Yes.
How many times do we add 3 to 2 to get 5?
1.
One time, right?
Yes.
So our formula so far is looking that like 5 equals 2 plus 1 times 3, right? How can we represent 1 in terms of 5's position? So how can we get 1 from 2?
You minus
subtract
1 from 2.
Yeah, so we
That's 1.
get 5 equals 2 plus its position, 2 minus 1 times 3. Everyone understands that?
Yes.
Yeah?
Yes.
Okay,
Yes.
so this is how we get that, right? If we replace the position with n, so let's say we didn't know the position of 5, we'd put this as n and we'd solve for n, right? So that's exactly what we did here.
Yes.
Everyone gets it?
Yes.
Yes.
Okay, so why don't you try this? What if I gave you, instead of 449, I gave you 452? How would we do this? How would I find what the position of 452 is?
Madam, change the number of sequences.
So what's the formula we would use?
5.
So we get a of n equals 2 plus n minus 1 times 3, right?
Yes.
Yeah?
Yes.
Okay, now where do I put in 452?
A-N.
Yeah. 452 equals 2 plus n minus 1 times 3, right?
Yes.
Okay, so now who wants to solve for n? Why don't you guys try solving for n?
Okay.
Okay.
Madam, should we say it or should we chat it down?
Yeah, you can type it into the chat. Oops,
Okay.
sorry.
Just
There we go.
Four 53.
153.
Is everything all right?
Ah. Okay. I only got one answer.
Three.
The answer is 3.
The answer is 3.
The answer is not 3.
Can you show us an example?
The
That's
answer is N is equals to
N is equal to 453.
We get 3n equals 453. Now what do? We should divide by 3, right?
yes.
So we get n equals what?
453.
No,
Madam,
but we can
can
divide
you give us
453 by 3,
that?
right? So we
The
should
answer
get
is
151.
5. The answer is 5.
Okay, well, let's try if the answer is 5, right? If the answer is 5, we get a of n equals 2 plus 4 times 3, right? Right? Is this going to give us 452?
No.
No, right? So the answer can't be 5, right? So let's go. So a couple people got the answer. So let me ask them. Uh, let me ask them if they want to explain how to do it.
Mommy, I found a way to make the audio work.
Go ahead and explain.
I was so close to getting the answer.
I got the answer by using the formula by 452 equals to 2 plus brackets n minus 1 times 3. I divided 453 by 3, which gave me the answer 151.
Yeah, so let's go through how we get 453. So we got 452 equals 2 plus, and we're going to distribute the 3, right? So we get 2 plus 3 minus 3, right? Everyone get this?
Yes.
Okay, then let's combine like terms. So we get minus 1, right? So we get 452 equals 3n minus 1, right?
Yes.
Okay, so now what do we do? We bring the 1 on the other side, right? So we get 453 equals 3n, and we divide by 3. So if we divide 453 by 3, how much do we get? How much do we get if we divide 453 by 3?
151.
Yeah, 151.
151.
Yeah. Is this sort of making sense to everyone?
Yes.
No, no,
Yes.
please.
What part do you not understand?
Same.
Huh?
The concept of it.
The concept? Okay.
The answer.
You don't understand why that's the right answer?
Yes, please.
Okay, so why don't we try plugging it back into the formula? So let's do a of n equals to 2 plus 151 minus 1 times 3, right? So if we do this, let's see what we get. We get 2 plus 150 times 3, right? And if we simplify this, we get it equals 2 plus 450, and that gives us 452, right?
Yes.
Madam, I don't understand.
You don't
What part do
understand.
you not understand?
Me too.
Wait, can you guys be a little more specific on like what part you don't understand? That way I can like re-explain it.
But I don't
But
understand how
Like,
you
just
answer.
what you just did right now.
Oh, what I just did? Okay, so
Madam
we
Varini, please, could you like start the whole question again? So the whole question again, and please make it a bit slowly this time.
yeah, I can do that. Okay, so this number is now 452, right?
Yes.
So
Yes.
can someone tell me what the main goal we had before to do? Like, what were we trying to do before? We are trying to match up the position of the number to the value of the number. Does that make sense to everyone? So if I say this is position X, how can I use X to get 452? Does everyone get that? That part's clear?
Yes.
Yes.
Yeah? Okay, that's
Yes.
our main objective. Okay? So now let's see if we can find a pattern between how these two are connected, right?
When we move to problem 2.
Huh?
When we move to problem 2.
Do you understand how to do this one?
Please can you give us another problem?
Understand why.
Please let's finish this one first.
Yeah, I just want to make sure you guys understand how to do this one before we move on to the other ones, because they'll use similar concepts. So, okay, back to this problem. Everyone understands main objective, right?
Yes.
What
Yes.
is the main objective? Who can tell me what the main objective is to solve the problem?
Is it to find the value of n?
Yeah, so basically what we have to do is we need to find the correlation between the value of n and the actual number. So that way we can solve for n. Everyone clear?
Yes.
Good?
Yeah.
Okay. So now let's see if we can find a pattern using the other parts of the sequence. So let's look at the number 5.
Yes.
Okay, what position is 5 in the sequence?
There's
What position is it?
Take a number.
2. Yeah, 2. Okay, so we get 2.
2.
So how many times do we add the common difference to 5?
2.
2.
Like, how many times do we add the common difference plus 2 to get 5? One time, right? We only
Yes.
add 3 once.
Yes.
So 2 plus 3 gives us 5. Okay, so let's write this down. 5 equals 2 plus 1 times 3, right?
Yes.
Okay, so we know that 5 is at position 2. So how can we relate position 2 to the number of times we are multiplying the common difference? Does that make sense to everyone? So how can we correlate the position with the number of times we use the difference? Does everyone understand that part?
Yeah.
Yes, please.
No? Okay. So basically what I'm trying to do is like, if we're adding 3 once, is there a way I can represent the number of times we're adding 3 using the position of 2?
Okay.
Okay? Everyone understand? Yeah?
Yes.
Okay, good. Okay, so now using 2, how can we come up with 1? So 2 plus some number equals 1, right? What is this some number?
Varini, please, you said 2 plus a question mark equals 1.
Yeah,
Is that by any
Mute your mic.
I couldn't hear the question.
please, is that by any chance like you can relate this to the number line to get the answer?
Yeah, so what we're trying to do is we're trying to see how this position number of 2 can tell us how many times to add the common difference to the first number.
So if I use that number line, will I be able to get the correct answer for this particular question?
So we're looking for a pattern in the sequence. And once we find the pattern, we can make a formula and use the formula to solve. So finding this number is like one part of how to find the solution. So we get the question mark equals -1, right? Everyone get that? How we get the question mark is equal to -1? Yeah? So we get 2 plus -1 equals 1, right?
Yes.
Yeah? Okay, so what we've
Yes.
noticed is that we can actually use the position of 5 at position 2 to get how many times we need to add the common difference. So with 5, we only needed to add the common difference once, right?
Yes.
So
Yes.
5 equals 2 plus its position of 2 minus 1 times 3, right?
Yes.
Everyone understand how I got this? Yeah?
Yes.
Okay.
Yes.
Sorry.
Please, a question.
Okay. So we get this answer, right? So now what we can do is that we can come up with a formula on how to solve this problem, right? So we know we can take the position minus 1 times the common difference plus the original number to give us some number in the sequence, right?
Yes.
Yes.
Okay. So now we can use this formula. We've come up with the formula we can use, right? We can use this formula
Yes.
to help us get 452, right? So
Yeah.
now we
Yeah.
plug in 452 into here. So 452 equals 2 plus x minus 1 times 3, right?
Yeah.
So now let's just solve for x. So when we solve for x, we get x equals 151, right? We already solved for this before.
Yeah.
Yeah.
Okay?
Okay.
Everyone understand?
Yes.
Okay.
Yeah.
Yes.
Yes. Yeah, but can you give us another one so that we know we're okay with the question?
Yeah. So there'll also be like questions that I can post on the Google Classroom that you guys can go over as well. And I will
Okay.
post the solutions too. So you'll get more practice problems.
Okay.
Yeah?
Okay. Hello, everyone. It's been an amazing time. Yes. Have we all really
Yes.
enjoyed ourselves? I know that it's been pretty tough, especially trying to understand, which I really applaud everyone. That's one thing about kids, they get to express themselves. So we want to keep to time. I promise that from next week is going to go well. Evangeline has been sad. I don't know what happened. Try to see how everybody, gets happy. So we would explore how to make this simpler version or dividing the classes, but we'll have to run this through with our facilitator Varini, okay?
Yeah.
But I hope we all, at least maybe out of 100%, we are 40% or 50%, we understand it 40 to 50% halfway, yeah?
Yeah.
Okay, please. So let's round off. I promise we would explore what we would do.
Please, may I ask one last question?
Yes, you can ask your question, but
You
I
were
want to say
saying
that, please, just one
Please,
more thing.
Alavani. Please, when you
excuse me, I can't hear you.
Alavani, please, when you put the questions
Hello?
on Google, please, may you also add the solutions to them?
Hello.
Yeah, I can show you where I could put the questions. So, okay, so we have this thing called a Google Classroom. And you guys can join the Google Classroom. So you need to have, oh, why is it like that? Oh, one sec. Okay, there we go. Okay, so we have this thing called a Google Classroom, and I will post the slides here, as well as like extra homework questions and the answers to all of it here. So one thing you guys need to do is you need to make sure you can sign into this Google Classroom. So I will put
How do
some,
you sign in into Google Classroom? Please, how do
okay,
you sign?
so there's a link I will send on the
Okay.
WhatsApp group, and you should be able to click it. And if you have a Google account, you should be able to join the Google Classroom.
Okay.
Okay?
Okay.
So I will do that after class, and please let me know if you can't get into it, because if not,
Okay.
I will send the information in the WhatsApp group.
Okay.
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 Okay. Varini, that will be all, yes?
Yeah.
Okay, please. Thank you so much. We would follow up with any more questions. But thank you so much for doing this. And
Okay.
we also want to thank the parents for staying up and providing the necessary support to the kids. So kids, thank you so much, and have a beautiful rest of the day, everyone.
Thank
Yes.
you.
Okay. Bye bye, everyone.
Bye-bye.
Bye.
Bye.